Our learning target here is to determine the empirical and molecular formula from the percent composition of a compound. And today, the success criteria is just like yesterday, to find empirical and molecular formula from the mass percent. Okay? Now, before we start out with this, I'm going to put a blank page in here. So we need to talk a little bit about the difference between an empirical formula and a molecular formula. What is the difference? Could it be the same? Could we have an empirical formula that is also a molecular formula? Could that happen? Absolutely. So I look at something like, let's check glucose. C6H12O6. Our good buddy from photosynthesis. Okay, plants make glucose. We use glucose in cellular respiration to get our ATP. Now, I look at that. Is there a way that I could reduce glucose down? Yes, it is. I can factor a 6 out of everything, right? So, glucose right here is a molecular formula because the empirical formula is going to be the reduced version, which would be CH2O. All right? Now, let's look at something else. All right? Let's look at something else. So I have C6H12O6. I reduce it down. Here's one we dealt with yesterday. Can I reduce that guy down? Aluminum oxide. Is that in its reduced form? Yeah. So this is both molecular and empirical. Okay. So if I cannot reduce it down any further, it will be both molecular and empirical. If I can reduce it down, it's molecular. Okay. And that reduced down form is the empirical formula. Now, right here is the very first problem we are going to work. So go ahead and copy this down in your notes, and then we'll work the problem. The problem states a certain compound has the following percent composition: 54.6% carbon, 9.0% hydrogen, 36.4% oxygen. The molecular weight for the compound is 176 grams per mole. What is the molecular formula? Well, the very first thing I need to do with the molecular formula problem is I need to find the empirical formula. So just like what we did yesterday, I'm going to find the empirical formula. And I'm going to start with 54.6 grams of carbon. I'm going to flux capacitor that into moles. So I know that 1 mole of carbon has 12.011 grams of carbon. When I do my math, I'm going to take 54.6. I'm divided by 12.011. My grams will cancel. It's going to give me moles of carbon, and that's going to be 4.55 moles of carbon. My next step is to find, 9.0 grams of hydrogen. I'm going to once again flux capacitor that. So I know that 1 mole of hydrogen has 1.0079 grams of hydrogen. My grams are going to cancel. That's going to leave me with moles of hydrogen. I do my math. 9.0 divided by 1.0079. That's going to give me 8.9 moles of hydrogen. And finally, I am going to go back up and look. I have carbon, I have hydrogen, I need 36.4 grams of oxygen. Flux capacitor that, 1 mole of oxygen, it's 15.9994 grams of oxygen. Once again, my grams cancel. It's going to leave me with moles of oxygen. I do my math, 36.4 divided by 15.9994. That gives me 2.28 moles of oxygen. Now I need to compare all of these. So I look and I can see that 2.28 is my lowest. So I'm going to divide everyone by 2.28. That's going to give me 3.9 and 4.55 divided by 2.28 gives me 1.99. So I look at this and I say, okay, is this close enough to 2? Yes, it is. So I'm going to say I have 2 carbon. Is this going to be close enough to 4? I would say a 3.9 is close enough to 4. Yes. And then I have the 1 here. So I'm going to come up with my empirical formula being C2H4O. Now, I'm not done yet because I need to see if that's my empirical formula, my molecular formula, or both. So how I'm going to do that is I am going to get the mass of this empirical formula. So carbon has 2. Each carbon is 12.011. So that is going to give me 24.022. Hydrogen, I have 4 of them. Each one is 1.0079. So that's going to give me 4.0316. Oxygen 1, and each one is 15.9994. So when I add those up, I get a value of 44.053. So that is my molar mass of C2H4O. I'm still not done. These are long problems here, folks. I'm still not done because that's the mass of my empirical formula. Way back in my problem up here, they told me that the molecular weight is 176 grams per mole. So I'm going to take 176 grams. I'm going to divide that by the 44.053. Why? Well, this is the molecular weight. This is the empirical weight. When I did that, I get 3.99. So this is telling me that my molecular formula is 4 times what my empirical formula is. So my empirical formula back here was C2H4O. So I need to multiply that by 4. So C2 is going to give me C8H4 multiplied by 4 is going to give me 16. O is going to give me 4. So my molecular formula is going to be C8H16O4. Now, what would happen, ladies and gents, if these two were equal? What does that tell me? Kaylin? That the empirical formula and the molecular formula are the same. So if those are equal, it's telling me both of those guys are the same. Questions about that? Okay. Now, what I want you to do is I want you to work this problem right here. Once you have this worked out, bring it up to me so I can check it. After you have checked it, you can get on with your homework for tonight.